So here we have that a relation is a function if and only if each member of the domain is mapped to one and only one member of the codomain. Now, since a function is a relation, a function is also a set of ordered pairs that can be represented on a mapping diagram or on a graph. So here we have an example of a one-to-one relation. So here we have the domain, which is a set of x values. And here we have the codomain, which is a set of y values. Now, because all the members of the codomain are mapped, this would also be the range. Now, if we look at our definition of a function, we are saying that a relation is a function if and only if each member of the domain is mapped. That means each member of the domain must be mapped. If you have a member of the domain that is not mapped, that would disqualify this from being a function. So each member of the domain is mapped to one and only one member of the codomain. So let's see if that's true. So we are seeing that each member of the domain is mapped, and each member of the domain is mapped to one and only one member of the codomain. Therefore, this one-to-one relation is a function. So I have written here a one-to-one relation is a function. So here I have an example of a many-to-one relation. So I have my domain here and my codomain here. I can see -2 and +2 is mapped to 4. So I have many, which means more than one, is mapped to 1. I have -1 and +1 is mapped to +1. So many going to 1. Now let's check this many-to-one relation against our definition for a function. So every member of the domain is mapped, and each member of the domain is mapped to one and only one member of the codomain. So let's see. -2 is mapped to 4 and 4 alone. +2 is mapped to 4 and 4 alone, because it's each member of the domain must be mapped to one and only one member of the codomain. So -1 is mapped to one member of the codomain, +1 is mapped to one member of the codomain, and 0 is mapped to one member of the codomain. Therefore, this many-to-one relation is a function. So here we have an example of a one-to-many relation. We have the domain here and we have the codomain here. So now each member of the domain is mapped, so it satisfies that condition where each member of the domain must be mapped. Now let's check to see if each member of the domain is mapped to one and only one member of the codomain. Now that happens here. This member of the domain is mapped to one and only one member of the codomain. And for C is mapped to one and only one member of the codomain. But when it comes to B is mapped to two members of the codomain. So therefore, this mapping right here, B is not mapped to one and only one member of the codomain. And that would make a one-to-many relation not a function. So I have a one-to-many relation is not a function. Now, because in a many-to-many relation, you'll also have the same type of mapping where you have one going to many. That will also make it not a function. So a one-to-many relation and a many-to-many relation is not a function. So the only two relations that are functions are a one-to-one relation and a many-to-one relation. So here I have a little note that only one-to-one and many-to-one relations are functions. Now we look at how to write functions. So if I have this function f of x is equal to 3x squared plus 2x take away 1, the name of the function is f. So I can have a of x is equal to 4x squared plus 3. And the name of this function would be a. Now the symbol in the brackets would be the only variable that's allowed in the function. So the only variable we've seen in this function is x. That's why I have the variable x in brackets here. So if I wrote f of x is equal to 5y plus 2, this would be wrong because I'm saying the variable in the function is x, but yet in the function my variable is y. So this would be wrong. In order to make this right, I either change the variable in the brackets and have f of y is equal to 5y plus 2, or I change the variable here and have f of x is equal to 5x plus 2. So the variable in the brackets must match the variable in the function. So this just means a function of x, where the function name is f, the variable is x, and this is the function. Here this would be a function of x, the variable is x, the function name is a, and this is the function. So this here would be a function of w, the function name is p, the variable is w, and this is the function. Now I can also write a function like this, where this f would be the name of the function, this two dots would be such that x is mapped to, so this x would be the domain, and what is mapped to, this would be the range. So I have x is mapped to 3x squared plus 2x take away 1. So here I have everything labeled. So the name of the function is f, the two dots is such that this x here would be my domain, this arrow means is mapped to, and this here would be the range. Now writing f such that x is mapped to 3x squared plus 2x take away 1 means the same as f of x is equal to 3x squared plus 2x take away 1. So I can write my function either like this or like this, but both of them mean the same thing. So in this question I have if p of x, so my function name is p, my variable is x, is equal to 3x plus 4 divided by x, we want to find p of 2. So what I'll do, notice that I have p and brackets x, and here I have p and brackets 2. So what I have to do is replace this x with 2. So if I'm replacing this x with 2, I must also replace the x here with 2. So I'll write p of 2 is equal to 3 open brackets, and that's because 3x means 3 multiplied by x. So replacing x with 2, so that'll be 3 multiplied by 2. Plus 4 divided by x, and replace the x with 2. So it doesn't matter how much times you have the x in the function, you replace all the x's with whatever is inside this bracket here. So you'll have 3 by 2 is 6. So you'll have 6 plus 4 divided by 2. And 6 plus 4 is 10 divided by 2. And that'll give you 5. So p of 2 is equal to 5. Now, what does that mean? It simply means that 2 is an x value, which would be a domain, and this 5 would be a y value, which would be a range. So it means 2 is mapped to 5 if you're drawing a mapping diagram, or you can write the ordered pair by having 2 as the x value and 5 as the y value. So that is what this p of 2 equal 5 would mean. 2 is mapped to 5, or the ordered pair 2, 5. So in this question we have if the function g of x, where g is the name of the function, the variable is x, is equal to 3x squared take away 5x plus 1, we want to find what is g of negative 2. So I'll be replacing the x here with negative 2, which means I'll have to replace all these x's with negative 2. So remember that 3x squared means 3 multiplied by x squared, and negative 5x means negative 5 multiplied by x. So I'll have g of negative 2 is equal to 3x squared, and we'll have the x, I replace it with negative 2 squared, take away 5x, and I replace that x with negative 2, plus 1. I'll have to work the powers first. So I'll square negative 2, that'll be negative 2 by negative 2, and I'll get positive 4. So I'll have 3 by positive 4, take away 5 multiplied by negative 2, plus 1. So 3 by 4 is 12, so I'll get 12. Then I have negative 5 by negative 2, which will give positive 10, and plus 1. So 12 plus 10 is 22, and 22 plus 1 is 23. So this answer would mean that negative 2 is mapped to 23. Or my ordered pair would be negative 2 and 23. So here I have if f is such that x is mapped to 3x plus 5, find f of 0. So first I'll write this differently, because I know that is equal to f of x is equal to 3x plus 5. This means the same as this. So now to find f of 0, I'll replace the x's with 0. So I'll have f of 0 will equal to 3 multiplied by 0 plus 5. 3 by 0 is 0. So you'll have 0 plus 5, which is equal to 5. So your ordered pair would just be 0, 5. Or on a mapping diagram, you'll have 0 is mapped to 5. So in this question, we have to copy and complete the table for the function f of x is equal to 2x take away 1, where the domain is given as x is greater than or equal to negative 3 and x is less than or equal to 3, which means x is between negative 3 and 3, inclusive of the negative 3 and the 3. So here we see the domain, and f of x would be our range, which would mean that f of x would be our y values. So first I'll write my function f of x is equal to 2x take away 1. And now my first x value is negative 3. So I'll be replacing the x here with negative 3. So I'll have f of negative 3 is equal to 2 times negative 3 take away 1. So that'll be equal to 2 times negative 3 is negative 6. So I have negative 6 take away 1. And negative 6 take away 1 will be negative 7. So that means my ordered pair would be negative 3 and negative 7. And in my table, under negative 3, I'll put negative 7 for f of x. So again, I have f of x is equal to 2x take away 1. And now I'll be working out the value of f of x when x is equal to negative 1. So I can put the answer for that here. So I'll have f of negative 1 is equal to 2 times negative 1 take away 1. So 2 times negative 1 is negative 2. So I have negative 2 take away 1, which will be equal to negative 3. So my ordered pair would be negative 1 and negative 3. So I'll be writing negative 3 here for f of x. So next I'll be working out the value of f of x when x is equal to 0. So I'll be replacing the x here with 0. So I'll have f of 0 is equal to 2 times 0 take away 1. Now any number multiplied by 0 is 0. So 2 times 0 will give 0, and then I'll have to take away 1, which will just be negative 1. So my ordered pair would be 0 and negative 1. So in my table under 0, I'll be writing negative 1. And my last value to work out will be here when x is equal to 2. So I'll be replacing the x with positive 2. So I'll have f of positive 2 is equal to 2 times positive 2 take away 1. So 2 times 2 will give you 4, so you'll have 4 take away 1. So I'll have 4 take away 1, which is equal to 3. So that will mean that 2 is mapped to 3. And under 2, I'll have 3 here on my table. So I've completed the table. So part B of this question, we're going to draw a graph of the function f of x being equal to 2x take away 1 for the domain x between -3 and 3 inclusive. So here I have my Cartesian plane. So my vertical axis would be my f of x axis, which is y, and my horizontal axis would be my x-axis. So the horizontal axis is the domain, and the vertical axis is your codomain. So now I'll plot the points in my table. So I have -3 on the x mapped to -7 on the y. So that'll be down here. -3 on the x mapped to -7 on the y. Then I'll have -2 on the x mapped to -5 on the y. So that'll be here. We have -2 on the x mapped to -5 on the y. Then I have -1 on the x mapped to -3 on the y. So that'll be right here. Then I have 0 mapped to -1. So that's 0 on the x-axis, which will be right here, and -1 on the y-axis, so that'll be here. So that'll be right here. Then I'll have 1 mapped to 1. So 1 on the x mapped to 1 on the y. So that'll be here. Then I'll have 2 on the x mapped to 3 on the y. So that'll be here. And then I'll have 3 on the x mapped to 5 on the y. So that'll be here. Then I'll take a ruler and connect the points with a straight line. And this will be my graph. So a point to note that f of x is equal to y. So it doesn't matter what the name of the function is, whether it be f of x, whether it be g of x, a of x, it's equal to y.